Morning e-learners.
Morning e-learners. Learners. Yes, learners.
Great English.
All right, any questions on the homework before we grade it? Questions on the homework? Nothing?
Take a cold shower.
Okay, quiet please. Quiet please. We're missing Josie. Anybody else?
Josie's absent. She's in Utah.
Julie. Oh.
And Julie. All right, grab your pen. Let's grade this. Here we go. Look at the paper, please. All right, so it's 2, 6, 8, 16, 20, 22. So for number 2, there was one answer that worked, and that answer was 5. Okay. Number 6, there was one answer that worked, and that answer was 3. Number 8, there was one answer, and that was 2. Number 16, there's one answer, and that was
1.
So 16 was the only one that was a little bit challenging. It was 3. Number 20, which 5. And the last one, number 22, the answer was 8. Very good.
You said there was multiple. You lied to me.
No,
Yes, he wasn't sure which one.
I wasn't sure. For my, listen please, for my honors algebra, I'm trying to find the one that has 2 answers. Number 34 has lots of answers.
Oh, my bad.
Number 35 has lots. So you guys just didn't get that one signed.
Do we get it to you now?
We will get that later. When we solve quadratics, you're going to see why you get 2 answers. We just don't have that yet. Yeah. Number 8 was 2, and 20 was 5. 5 times 5 is 25. All right, Aiden. I don't know what you're doing. Please stop. All right. Do me a favor, Aiden. Walk around, collect homework. And Sophia is passing out papers. Everyone else, what do we got going on tomorrow? Well, I hope there's not a test. No, there's nothing like that tomorrow, but that's Friday is the quiz. On tomorrow, I will tell you what will be on the quiz so that we can start off with a rock solid A for everyone. Okay? Homework tonight is as follows.
Is it 38 and 4 total?
Yes. I didn't want to write 38 through 40 evens. That seemed like too much to write. I'm listening. Well, the reason why we bring a math book in class is 2 reasons. One, if we do have extra time, you get started on your homework, and then obviously for student advisement. And then 2, if I say something, I teach from the book. So, most of the examples come directly from the book. So if you were trying to look ahead or look back, you could see it, because remember, I'm going to flick the slides. So if you were trying to copy down a definition and I flipped the slide, at least you would have a chance to turn the page and copy the definition.
8 times in number.
All right, we ready? All right, here we go. So today's lesson, all right, kind of medium. It's not too complicated, but some people definitely struggle with this. I don't want to pry, but anybody here English language learner, like English was not your first language? So a lot of kids, that is the case, right? Translating English words into math is a challenging thing because English is not their first language. For the rest of us, obviously we all speak English, but it becomes challenging when just a few operations. Subtraction is the notable one that generally, if there's a mistake, subtraction. You have me last year, you did this class before. We just make it more complicated this year. But it's literally, I mean, I use the same slides as last year. They may look familiar to you. Remember. All right, lots of objectives. We'll talk about them as we get there. So today's basic idea is I'm going to give you a sentence or sentences. You're going to write an expression. Okay? I'm going to give you words. You're going to write the expression that's equivalent to those words. So writing variable expression. They will all be variable expressions. All right. That's horrible. You can't see it. I need to change that from white to black. The objective or the goal is we're going to write the expression that represents that phrase or sentence or sentences. Okay? So what does that look like? Red. Write this down, please. We first need to talk about operator vocabulary. Remember, we did this last year. Operator vocabulary are those words that represent one of the four, there are more than four, operational symbols. The four operational symbols that we will be concerned with are plus, minus, and so forth, multiplication and division. So we're going to write this. I'm not going to give you a all-inclusive list, like I'm not going to list all the words. I'm going to show you the main words, and I try to, from homework, pick out those words. Kylie, you got the first one. Plus. Give me a word for plus other than plus.
Twice.
I said Kylie. Kaylee. I don't know why I said that. Kaylee, give me a word for plus that isn't plus. Add. Rylan, give me another word for plus that isn't plus or add. Sum. There's two big ones. Add and sum. There are some more. Write these down. Total. The total of 2 and 3. That means add 2 plus 3. 2 more than 3 means add 2 plus 3. 2 increased by 3 also means 2 plus 3. These are kind of the big ones, those 4 words. If you see any one of those 4 words, they're asking you to do addition. Does it sound familiar from last year? It's the same slide, by the way. And probably last year I said that, I should make that not white, but black or red or something. And I didn't change it last year. Chris, the next operation symbol we're going to use is subtraction. Make sure you're writing this down. Can you give me a word for subtraction that isn't subtraction? Take away. Now, our book will never use take away, but that's absolution. What do you got?
Less than.
Less than. 2 less than 5 means 5 minus 2.
Decreased.
5 decreased by 2 also means 5 minus 2. And then there's the $10 word. Minus. No, that's the 10-cent word. I guess you might see minus. There's a $10 word for subtraction. And it ain't take away. And A minus. What's the $10 word? Come on, you've seen this before. No. It does start with a D, though. Anna, you're letting me down. Nobody knows the $10 word?
I slightly remember it.
D I
Did.
F.
Difference?
Write that down.
You guys didn't know it, loser.
Well, neither did you.
So I will say 9 times out of 10 they use the word difference. And this is the one we're going to spend some time on, difference. It's the one that almost everyone screws up. But you will see fewer than, decreased by, less than. Subtracted from, okay, that's kind of the giveaway. I mean, you're not going to make a mistake on that one. But difference is primarily the word that they will use for subtraction. What are you guys doing? Rylan, am I going to go to class without saying the word Rylan?
Yes, yesterday. You said my name once.
I have video.
Like 4 times.
Yeah, you didn't say it once yesterday.
Not
No, except at the beginning of the day, because we just came into class. You were like, "How you doing, Rylan?" And that was the only time you said my name.
Can I use your book to throw my
All right, Sarah, multiplication. Give me the $10 word for multiplication. You know it? Yes, no. Okay. Who knows the $10 word for multiplication? What?
Is it product?
It is product. right? So for multiplication, the $10 word is product. They will use times. You're like, well, that's the 10-cent word, but they will use times. So you'll see product or you'll see times. If you see the word times, it's not 2 times 3. They will say twice the value 3 or 2 times a number X. Something like that. Nathan, you know the $10 word for division? You already got one. $10 word? Quotient. Okay, so quotient is universally used for division. There's only a few times I've ever seen them say divided by. Almost always they say quotient. Quotient is just the fancy word for division. So these are the words, for those of you already looking at your homework, that they will use when you get these phrases or sentences. And remember, our big goal here, I'm going to take this phrase or sentence, and I'm going to write a mathematical expression that means those words. Of all of them up there, that's the one you're going to make the mistake on. If you ever see difference less than, decrease by, fewer than, you better take a moment and make sure you got it right. It'll be the one you make the mistake on. The rest of them, it's hard to make a mistake. But subtraction mistakes all the time. We good? Okay. So now we know the words that represent the operators. Now we're just going to do a whole bunch of examples. Okay, and I said subtraction is one we've got to be careful with. Remember, our goal is I'm going to give you some words, and you're going to write an expression that represents that phrase or sentence. Okay. I'm big on steps. I'm going to not force you to write this down, but if you're one of those persons, like, you just tell me the steps and I can do it, write them down. Okay? Did I already print this off for you or no? I did not. So the steps are identify whether you're adding, subtracting, multiplying, dividing. How do you do that? You find those operator words: difference, quotient, increase by, decrease by. Okay, now I know what I'm doing. I'm adding. They're going to give you at least one number. You'll see when you do some of these examples. They're going to give you at least one number. So identify what numbers you're dealing with. Okay? Generally, on every one that we do today, I think everyone, there's going to be a variable. Now, sometimes they will say something, for instance, the variable x increased by 2. They're very specific. Most of the time they will, are you listening? They will simply say a number. If you see the words a number, they're asking you to make up a letter. Whatever letter floats your boat. I'm going to probably always use X. Okay? Lastly, now you know the numbers, you know the variable, you know whether you're adding, subtracting, multiplying, divide. Write that sucker up. If there was a last step, it would be read it to make sure it matches. So for those of you that like steps, there you go. For those of you who are like, nah, I'll just read the whole darn thing and figure it out myself, go for it. You can still do that. You okay? All right, so let's do some. So in blue box here is what we're doing. Porter, read that. Okay. What are we doing? Add, subtract, multiply, and divide. And how do you know? How do you know? Because it literally says increase by. That was one of our operator words. So that we know that we're adding, we're plussing, right? I made that word up, plussing. All right, we're adding. Are there any numbers here, Porter? Which one?
3.
Does it say 3 increased by, or does it say increased by 3?
3.
What?
Increased by 3.
So increased by 3. Do we want to put the 3 on the left or the right?
Right.
Why? Why do we want to put the 3 on the right and not the left? This is actually the key question right here. Why do we put the 3 on the right? And he's right, it's on the right, and not the left? What does it say? Increased by 3. If you put the 3 right here, what are you increasing it by? I don't know. Whatever is over here. Whatever over here is what you're increasing it by. Operator symbols always apply to the number on the right. If you're multiplying by 3, the 3 goes on that other side. If you're dividing by 3, it goes on the other side. If you're adding 3, it goes on the other side. If you're subtracting 3, it goes on the right side. So we don't want to put it on the left side, because then we don't know what it's being increased by. Now it's something is being increased by 3. I don't know what. Oh, by the way, Porter, what's being increased by 3? What number are they talking about? Exactly. He shrugged his shoulders. I don't know either. So in math, when you don't know what the number is, what do you write? You write a variable. Whatever one of the 26 letters that floats your boat, I use an X. Now, if it said a number F increased by 3, then that needs to be an F. Okay? But in this case, it's up to you. Who's lost? Simple, right? This was last year's slide, by the way. Okay, let's see. What did I say was the one that was going to mess you up? Which operation symbol did I say would mess you up?
Subtraction.
Here's a subtraction. How do I know this is subtraction? Fewer then. Okay, you got to think about this. If I have a pile and I subtract from the pile, where does the number go? On the right or on the left? If I subtract, what am I subtracting by? What am I subtracting by in this case? 7. I'm trying to subtract 7. So does the minus sign go there or does it go there? Look at it. You tell me. Which one says subtract 7? When I put the subtraction symbol on the right or on the left? Okay. Somebody said on the right. What does that say? Are you subtracting 7? Okay, I'm going to put a number there. Are you subtracting 7? That says subtract 7. What does it say? This is why the subtraction symbol needs to go on the left of the 7. That says subtract 7. What did I say you'd screw up on? Why does everyone want to put the subtraction symbol on the right side? Because that's what it says. Does it not say 7 minus in words? Mathematically, what it means and what the words say are two completely different things. And subtraction is the only one that's like that. It's because of the English language. I don't know about other languages, but I know in English, we write subtract 7 like 7 minus. 7 minus, right? When we write that in words, it's not the same. 7 fewer, mathematically is written as minus 7. So be really careful when you do subtraction. Really careful. Read it 3 or 4 times. Convince yourself that when you write that minus sign, that your number is on the right side. Or if you want to think about it, the minus sign is on the right side. And I mean right, I should say the word correct side. As soon as you say right, then people are learning thinking right or left. Who's lost on that? Or do you understand the importance of this one? Right? It really looks like you should write 7 minus. But the words don't literally mean 7 minus. It means 7 fewer. This means 7 fewer. Finish it up. What do I got to put? Somebody help me out?
T.
You got to put T. So this is 7 fewer than T. Kind of weird. I just went from right to left. And that's just because of the way English works. Okay?
Mm-hmm.
All right. The rest are pretty simple, right? We haven't talked about the commutative property, but multiplication and addition are commutative. 2 plus 3 is the same as 3 plus 2. 2 times 3 is the same as 3 times 2. So even though if you write this backwards, you still get the same answer for multiplication. Okay. All right. Sophia, what do you think? What are we doing? What's the operation? I know you weren't. So rule number 1 is always, if you choose to do your homework, what do you got to do? You got to at least stay with the class. Blue box. What are we doing? What operation symbol? We're doing multiplication, so I need a multiplication symbol. I put a dot. Keep talking. It could be x times 10, right? We generally, when we see this now, I wrote it exactly the way it reads. Remember, like I said, multiplication is commutative. 2 times 3 is the same as 3 times 2. It doesn't make a difference. Generally, we always put the number in front of the variable when we do multiplication. In this case, that's perfectly fine. I wouldn't mark you wrong for that. Multiplication, easy. All right. So here comes our first Algebra 1 question. The rest were like copies from previous years. Okay. All right, Piper. Can you pick out in all those words the operation word? Right? Are we adding, subtracting, multiplying, or dividing? She says multiplying. Anybody want to argue?
Multiplying and adding.
There's actually 2 operations. Last year you only did 1. Now you're going to do 2. You're now to 1. Welcome, big boy, big girl. Where do you see the 2? Go ahead. Where did you see the 2? Where did you see the 2? Where do you see the 2 words?
More and twice.
More than means addition. Twice means it's hard, right? So I got 2 operation symbols. So when you have 2, I'm not going to give you one with 3. When you have 2, be careful. Now we got to pick and choose what we want to say. What do you want to do first, add or multiply? Or what do you want to work on first, the add or the multiply? It doesn't make a difference. Which one? You get to pick. What? Let's do addition. What's being added? 3 more. How do you write 3 more? No. Plus 3. Once again, it's that English stuff. Remember, if you say 3 plus, what are you adding? I don't know. This is why 3 plus is written as plus 3. Plus 3. Granted, it doesn't say that. It really looks like it says 3 plus. But plus 3, or is it 3 more is plus 3. Who's lost? Okay. I forget if my slides I did addition or multiplication first. So that's the addition. What's the multiplication? Somebody, what's the multiplication?
2 times m.
2 times n. Where are you getting the 2 from? I don't see the word 2 up there at all.
Twice.
Twice means 2 more than. It doesn't mean 2 addition, like add 2. Twice means you're multiplying by 2. So if we put together the plus 3 with the twice, what was the variable?
N.
It tells us to use the variable n. There you go. There's an Algebra 1, words to expressions. Intimidated? Not intimidated what? I would be intimidated, right? Especially for the subtraction ones. Especially for the ones that have 2 things going on. So we better do a couple more. All right, here's the rule for quotient. Quotient means what? Division. If you see the word quotient, now pay attention. If you see the word quotient, quotient means division. And Algebra 1, how do we write division?
Fraction bar.
Fraction bar. If you see the word quotient, this is the word quotient. Not technically, but sort of. This is the word quotient. The word that comes right before quotient goes on the top. The word right after quotient goes on the bottom. Hey, I made a division symbol. What do you know? I'll say that again. The word quotient, kind of like the fraction bar. The word right before the word quotient goes on the top. The word, I mean the number. And the word number right after the word quotient goes on the bottom. That's what quotients are easy. You can't mix up their order as long as you remember that rule. Do I need to say that again, or we got that? You see the word quotient. Where's quotient? There's going to be something right in front of it, right? Quotient of 6 and a number. I said that. These are not the droids you're looking for. Okay? Boy, did I screw that up. All right, let me try that one more time. If you see the word quotient, I see the word quotient. Right after it, you're always going to have 2 numbers. What 2 numbers do you see? 6 and, well, there's a variable. It always goes top, bottom. When you see the word quotient, then it's top, bottom, numerator, denominator. When you see the word quotient, numerator, denominator. I'm sorry, I messed that one up. We okay? Now that I've confused you? All right. All right. So let's see if we can do this one. All right. Which is the one you got to be careful with?
Subtraction.
We got subtraction. How do you write 9 less?
times.
So at least I got one person that will catch on. It'll take some of you a while to catch on to this. 9 less is not 9 minus. It sure looks like it should be 9 minus, but 9 less is minus 9. This is 9 less than something, and that something is the quotient of two things. What are the two things? 6 and the number n, right? So this is your top, this is your bottom, or your numerator, denominator. It will always work that way. So 6 and a number n. This is 9 less than the quotient of 6 and n. Even though I screwed up quotient, right? You should never screw up quotient because it's simple, right? 6 goes on the top, n goes on the bottom. Why? Because it's literally the first thing goes on the top, second thing goes on the bottom. I said that part right, but I didn't say the other one right. We okay?
English is hard.
English is hard. Well, actually, I messed up the math. I didn't mess up the English. All right, nobody's complaining. Moving on. This is the second or maybe the third Algebra 1 question. You don't see this in pre-algebra last year. All right, this is hard. What does the word product mean? No? Okay, when you multiply, how many numbers can you multiply at once?
2.
Can you multiply 3 numbers at once? Sorry. Mr. Chardier's room. What's up? Yeah, I'm in class right now. Yeah. Okay. All right. Can you help a student with a locker problem? Nope, can't do that. All right. Product means multiplication. I left off. How many numbers can you multiply at once?
2.
How many numbers can you add at once? How many numbers can you add at once? Can I do this? 41, 37, 64. Can I add those at the same time?
Yes.
Sure can. Can you multiply those at the same time? Nope. I mean, how would you do that? Have you ever multiplied 3 numbers at once?
41 times 37 equals.
I mean, at the same time. I mean, I'm going to go 4 plus 7 plus 1. I mean, I can literally add 3 numbers at once, or 4 or 5. I can't multiply more than 2 numbers at once. So when you see product, right, it's 2 numbers. It's something times something. Now the question is, what goes where? Okay? Just like quotient, guess what happens? The first thing right after the word product, guess where it goes? Right there. The second thing goes right here. And why am I making a big deal about this? Because this one's different. What goes right here?
4.
What goes right here?
7.
It says the sum of n and 7. So guess what you kind of want to write? You really want to write, what, n plus 7? And it's wrong. Why? Because of PEMDAS.
7 plus 7.
Is 4 being multiplied by the 7?
No.
Is 4 being multiplied by n?
No.
Sure it is. 4 times n plus 7. Is that what that says?
No.
This says the product of 4 and the sum of n and 7. I kind of just gave it away. Guess what you got to put? You got to put parentheses. Why? Because how many numbers can you multiply at once? 2. So I need this times whatever comes after it. But what comes after it is n, the sum of n and 7. That's n plus 7. So what is that going to look like? Right? Well, it's multiplication, and the first thing is 4, but the second is the sum of n and 7. It doesn't say the product of 4 and n. Otherwise, it would say that. It doesn't say that. It says the product of 4 and the sum of n plus 7, or sum of n and 7. So that's how that looks. Algebra is hard. I would fully expect many people to miss this one, especially tonight for homework. How do you know this stuff? Well, that's why I'm teaching it to you. You got to learn this. The same thing with quotient. If you ever see the word quotient, first word after it, or words, is the numerator, and the second thing is the denominator. Product, the first thing after it is the first number. Second thing that comes after it is the second thing. All right. If I were writing this, I would have said the product of 4 and the quantity of the sum of n and 7. And that kind of really tells you you're dealing with parentheses. I'll just tell you this is a question on the test. Not the quiz, but the test. Test is what, next week? So I just gave you. Now, we generally don't put a dot, right? You remember the distributive property from last year? Right? We generally write it. I would not mark that wrong, but that's how we would write. Who's lost? On this one, right? The previous one? Previous couple? Okay. So let's do some together. I have this in green, but if you want, we can do them together. All right. Do box, what is it? 3?
Yeah.
Do box 3, and if you want to work together, we'll work together. All right. First one, what am I going to write? We're done. Now, remember what I said before. We generally write number first and then variable. If you wrote x times 6, perfectly fine. You're going to learn 6 is called the coefficient. All right, the next one, 4 more than a number t, number r? Yeah, number r. So what am I going to write?
R plus
4 more. Now, 4 plus r, what is being added?
4.
This one I'm adding r, and this one I'm adding 4. So if it says 4 more, then it's got to be r plus 4. Yes? I'm not hearing complaints. 8 less than a number t. You really want to write, I shouldn't even do this. What do you really want to write when you read that?
8 minus.
You really want to write 8 minus. But if you write 8 minus, what's being subtracted?
T.
Something here, and I didn't write that. If it's 8 minus, that says 8 minus. This doesn't say 8 minus. This says minus whatever's in this box. So 8 minus, or 8 fewer, or 8 less, is written as minus 8. And this takes t, so it's t minus 8. We okay? Subtraction will kick your butt. 3 less than twice the number n. 3 less. How do you write 3 less?
Minus 3.
Okay, you can't answer anymore. 3 less. It's got to be minus 3. Twice the number n, 2n. Hey, do not let me roll over you guys like you're really lost and you're sitting there while I'm just yelling out answers. And I have other people in my audience that are yelling out the answers as well too. That gives me the wrong impression that everyone's on track. You got to be brave in Algebra 1. If you're not saying anything, yes, I'm going to assume you got this. And we'll figure it out on the quiz and test that you don't have this. Yes? How do you write twice a number n? How do you write twice your age? What would you have to do mathematically? You have to multiply by 2, right? This is 2 times, it doesn't tell us what, it just says a number n. How do you write 3 times a number n? Yeah, but how do you write it mathematically? How do you write 3 times? So, 3 times the number n would be 3n. 3 times a number n. Okay. We could also, there's other words we could use. What are some other words we could use for multiplication that are commonly used in English? You want to multiply by 3, you could also say it's triple, right? I don't think I ever used that, but you could see that. Quadruple b times 4. All right, the more challenging ones. 4 more than the quotient of h and 7. Aiden?
Plus 4 and then 8 over 7.
Oh my word, I created a monster.
Or is it?
No, you had it right. I got to write really small, but yeah. He said plus 4, and then he said quotient. You just had to squeeze those two things together. Brilliant. Good job. Last one is the hardest one. It's the one with parentheses. Go for it, Anna. Now, she said it the right way, but she said kind of like she put the 2 on the back, and you could. How do I know? The product of 2. Whenever you see the word product, think multiplication and think there's something times something. The very first thing that happens after the word product is the first thing. And the second thing, then it says the sum of, well, the sum of it will be a plus. If I just write 8 plus n, this 2 is being multiplied by the 8, but the 2 isn't being multiplied by the n. The only way you get 2 times this sum is to put parentheses around it. Now it's double the sum of 8 and n. Guess when we're going to use this stuff this year, by the way? Oh no, we're going to use it all. Guess when we're going to use this?
Tomorrow?
What kind of problem? Your favorite? A word problem, right? Yeah. So whenever we do word problems, this is the language that they're going to use to set it up. So you got to be comfortable with this. We do plenty of word problems in Algebra 1. We okay?
Mm-hmm.
All right. Cool. Here's your toy, kitty. Here's your toy. Get your toy. Oh, get out of the way. All right. Nothing to do with math.
Lay there and was like, wait.
All right. You can't get cats to do tricks, right? Dogs do tricks.
Some cats can. Hey, don't be discriminatory.
The only trick my cat does is scratch,
I just
right?
want cats to be decoration.
My cat can do that one trick very well.
Yeah.
Okay. So, big picture. Let's do the opposite. What would the opposite be? What's the opposite of what we just did?
Turn equation for turn the equation.
Except we're not going to call it an equation. We're going to call it a.
Problem.
Notice we didn't have an equal sign. Not an equation, but not an equation. So before I gave you the words, you turned it into an expression. So the opposite or the reverse of that would be, now I'm going to give you the expression. You got to turn it into words. Right? So, some examples. There we go. Rylan, you're up first.
Yes, sir.
Turn that into words.
3 times a number.
Is he right?
Yeah.
Okay. Is there any other way we could say that?
Twice times a number.
No, that'd be wrong.
Triple times a number.
Triple of number x. Anything else? Use all those words. What do you got?
The product of 3 and x.
Okay. All of those are pretty good. Okay. So when you do these, there's like an infinite number of ways of saying. I'm exaggerating, but there's lots of different ways to say that. Okay. All right. 3 times the number x. Right. How about this one? Go.
7 plus x, number x.
Okay. So was plus one of our words?
More than.
Try it again.
7. The sum of 7 and x.
Okay, that's one way. The sum of 7 and x. Another one?
7 more than the number x.
7 more than x. Right? Anybody else? What?
The total of 7 and a number. Or,
Yeah, fine. Right? All sounds good to me. All right. What did I say? I said 7 more than the number x. All right, some more. Ooh, here we go. Go ahead. Haley, go.
5.
First off, what's the operation? It's division. So what's the $10 word for division? So say it. Okay. So quotient is like the word product. We're going to say the quotient of. And remember, it always follows. The first word after the word quotient is the numerator. Second one's the denominator. Is that what you're going to say? Well, too? You can say that. So you do the next one. Ooh, she's in a corner now. How's she going to get out of it?
Less than 1.
Nope. That would actually be, the way you said it would be 1 minus 2x. You said the product of 2 and x less than 1. So give it another shot. And I'll give you the hint. Whenever there's subtraction involved, start with a subtraction.
1 fewer.
Ooh, I like that.
1 fewer than 2 times a number.
Yes? She said 1 fewer than 2 times a number. Is that not what it says?
Yep.
Yep. Here's another one. 1 less than. I mean, it's literally what she just said. So if I chose 1 less than, she said 1 fewer. Any other way?
Different.
Use the word difference. Show me what it would say.
1 difference.
No. The difference of.
The difference of 1.
You choose to use the $10 words. What are the $10 words? Difference. What are the other ones? Product and quotient. If you choose to use one of those $10 words, it follows the same pattern. The first word after one of the $10 words is the first number, and the second word after the word one of these $10 words is the second number. So if you choose difference, you would say the difference of. If you choose one of the $10 words, the first thing after the $10 words is the first thing. So the difference of and that's how you would say it. So the difference of 2x and 1. So in some respects, using the $10 word makes your life a little bit easier, follows the same pattern. I'll just say subtraction is rarely used with the $10 word because I don't know why. They just don't tend to say that. But if you choose to use a $10 word, it makes your life a little bit easier. All right, do these 3 and we'll call it a day. Box 4. Box 4.
I already did that.
You already did it?
Me too.
I lied. There's a back. I thought I was done. I'm not.
Thank you.
We've won. At what cost?
You don't like my lines? You need a new notebook, maybe. You need a better notebook. How could it not fit in your notebook? You call me fat? I thought all notebooks would be able to. It's just a regular sheet of paper. 8.5 by 11.
It's special paper.
All right.
Magic.
All right. Let's see. Michael, I haven't heard from you today. First one, what do you got? Difference of a number t and 6. I could also say
A number decreased by 6.
a number decreased by 6. I like that. And
There you go.
Yeah.
6 less than
6 fewer or less than
I do know
a number. All right, go ahead. Second one.
the quotient of x and 4.
Quotient of x and 4. Lots of different ways. What did you write? Lots of different ways. What did you write? If you write t less than, this is t less than something. I'm subtracting t from, if you say t less than, subtraction will kick your butt. It will kick your butt. All right, who wants the last one, which is the hardest one?
Quotient of x. Yeah.
Last one, Rylan, what do you got?
Last one. Like just writing a different form or.
I want words,
Oh, words.
and then I want you to pay attention because clearly you didn't do the page.
Okay, so it would be. Isn't it F subtract? But no.
And if you're paying attention, you will get this. You got to pay attention. Go ahead. Landon.
F less than 5 times 2.
No. You said F less than what?
5.
5 times 2. That's what you just said. Is that the same thing?
No.
It's not. Go ahead, Tristan.
The product of 2 and the sum of 5 and a number x. Yeah.
You almost had it.
Almost.
You said sum. Sum means addition. This is subtraction. I mean, you're really close. What do you got?
2 times 5 minus the number f.
No. She said 2 times. Oh, wait, say it one more time.
2 times 5 minus the number f.
No. No, I didn't think about that one. How do you, we're hung up on this part. How do you say that? There's a couple different ways. Go for it. The easiest way would just say the difference of 5 and f. Now, if you want to use those other words, it would be f fewer than 5, or 5 decreased by f. Right? That's kind of weird, but if you want to use the $10 word, then it makes your life easier. So this will be 2 times the difference of 5 and f. Okay? All right. Let's get to the last thing. You ready? Riley, you paying attention now?
Yes.
All right. Write this down, please. Box 5. There are a couple formulas that you need to use tonight for homework. I will show you all the formulas. The definition of a formula are equations that state rules about relationships. Sounds like we're dealing with boyfriend-girlfriend here, but we're not, right? So what are you guys studying in science right now? Like, for instance?
Scientific method.
Okay, yeah, that's right. You always do scientific method. So I know that the 8th graders, they're doing physics right now, so they're learning the relationship between distance, time, and rate. Remember that from last year?
Oh
What's the formula?
yeah. Absolutely no clue.
Sorry, but
I always call it the dirt formula. D, R, T, and there's an equal sign. Distance is equal to your speed, right, or your rate, times how long you're doing that speed. Hey, girls. Right? So this is an example form. Why? It states the rules. The rules is if you want to find the distance, you got to multiply the rate times the time about the relationship. So the relationship is the distance is equal to the rate times the time. It also means that T is equal to D over R. Remember doing this last year? And R, I'm just doing a little bit of algebra here. R is equal to D over T. You get these 3 formulas all about distance, rate, and time. Okay? We will use some of these this year in Algebra 1. So some of the primary ones that we were going to use, now there's the classic example of a formula. We're not using that this year, right? But that's your standard. Anybody know what it means? This is Einstein's theory of relativity, or one of his theories, I should say relativity. What? No. Anybody know what it means? E stands for?
Energy.
Energy is equal to
Mass
times
square. No, square.
Circumference.
speed of light. So energy is equal to mass times the speed of light squared. Okay, that's an example of a formula. It's usually when I say give me a formula, somebody either gives me the Pythagorean theorem or that one. Okay, write these down. Box 6. Write them all down. What's that the formula for? Anybody? What's the formula for?
Area.
Of a
Rectangle.
area of a rectangle is equal to length times width. That is the area of a rectangle. Tonight for homework, when they talk about the area of a rectangle, it's that formula right there. What's that one? Of a rectangle. The perimeter of a rectangle is 2 lengths plus 2 widths. P for perimeter, obviously.
it's all flooding back to me.
I will slow down. Well, there's our dirt formula. This is a relationship of distance traveled is equal to your speed. They don't use an S, they use an R because they call it rate. That's what it means. Speed times time. And the last one, oh no, that's the last one. Okay. You will need all those formulas. Lunchtime.
I have to fix this. Turn it off now. It's torn off now.
You have first world issues.
By the way, which issues are you referring to?
No.
Does it really matter?
Doesn't really matter.
No.
Does
All right, e-learners, remember we're going to have a quiz on Friday. We'll talk about it more tomorrow.
Do they hear